are you, everybody who is watching this fantastic video? I would like to take this opportunity to welcome you into these fantastic moments of learning the beauty of electronics and telecommunication engineering. My name is Olenjolai. I thank God for the gift of teaching. I have been teaching for more than 14 years. And I'm still teaching, and I will keep teaching ever and ever. So today, I'm going to teach you about a particular concept of how can you solve a real-life electronics engineering problem. So for the online students, good thing that I have some local students. And these students are actual first-year engineering students in electronics and telecommunication engineering in one of the institutions that called DIPLOMA Institute of Technology. So for the local students, they will have a chance to ask you questions. And for you who is online, just use the comment sections there in order to ask questions about what we are going to cover. So one thing which I want to tell you that I'm extremely serious in teaching. So even yourself as a student, make sure that you are serious. Any engineering students should have a pen, should have a pencil, should have a ruler, should have an exercise, and you should have a fresh mind to receive the content that I have prepared for you. Our workshop or our class today will take almost 90 to 100 minutes. So you should have a good stamina to make a follow-up. And I'll be writing on the blackboards and explain. So you have to listen, and also you have to write the contents. So in order to appreciate and acknowledge the presence of the local student, you will hear their voice. Good morning, class.
Good morning, sir.
Good morning, class.
Good morning, sir.
Are you ready to learn the beauty of electronics and telecommunication engineering?
Yes.
Wonderful. So I think even for you who are offline or who are online, but just through these contents, you are ready. So let us go. So whenever we want to solve any real-life electronics engineering, let me just tell you something. I told you that engineering, this is all about introduction. Introductions of this concept. I told you that, and I would like to remind you again. Engineering can be summarized. Can be summarized into 5 main parts. 5 main parts. The first one, I told you that engineering is all about numbers. All about numbers. Say numbers. Then the second one, I told you that engineering is all about formulas and the equation. That's why we need mathematics in engineering. Also, I told you that the 30 components of any engineering, or in any, either it's mechanical engineering or electronics engineering, I told you that in engineering, we have to deal with some we call them diagrams. Say diagrams. And then the first part, or the first main parts of any engineering field, engineering is all about tables. All about tables. And then number 5, or the fifth part, engineering is all about graphs. So these are the 5 main parts that you can summarize any engineering field or any engineering concept. You can summarize into these 5 parts. When you say numbers, it means that we can have numbers and letters. When you say formulas and equations, this is the point that we see the applications of mathematics. When you say diagrams, we talk about diagrams. Every engineering field has its own diagrams, right? Whether it's computer engineering, it has its own way of drawing diagrams. Whether it's telecommunication engineering, we have our own ways of drawing diagrams. But another thing is tables, and another thing is graph. So remember that I told you that engineering is a purposeful use of 40. Remember that. So what is engineering? So I told you that engineering is the purposeful use of 40 of science. So if it is a purposeful use of science, these 5 elements or parts of engineering are not new in your mind. You have learnt them during your primary education, so primary science and secondary science. Are we together? But when it comes for the college level, we add some value. We add value. For instance, When you say that in science, as science, if you do remember, you remember that you've been doing a practical in a topic called mechanics. And that practical, actually, we can be asked to find acceleration due to the gravity. Right? The aim of experiments to determine acceleration due to the gravity. Right? You'll be given instructions in the questions, and also there's the diagrams, or we call experimental setup. Okay? So then, you will find that you'll be given instructions how to do that practical. Then, let me just say for the case of for the case of electricity. So in case of electricity, for instance, you can be just asked that or fill the table below. You can be given a table, or you can be asked that to draw maybe a table like this. So suppose that you've been given different values of resistor. And then you've been asked you to find, maybe you've been given a specified maybe voltage. So you've been given resistance, and then voltage. Then you've been asked maybe to fill the columns for for current. So you can have something like this one. I'm just giving the overview. So you can be given a certain value of resistance, let's say resistor 1, and then resistor 2, and then resistor 3, and then resistor 4. In case of voltage, you might be given voltage 1, voltage 2, voltage 3, then voltage 4. So you have to do experiments in order to fill. It means that when the resistance used in the circuit is R1, and the voltage is V1, you can measure the amount of current flowing in that circuit. Are we together? Yes. So you are asked to fill this table. So when you fill, so suppose that you have filled and you got I1, I2, I3, I4. Are we together? If you do remember that, the next part, which we have asked you in science to do, is you have to draw the graph. Okay? So the graph, it depends to the nature. But maybe you can ask that, draw the graph of what? Draw the graph of current against the reciprocal of resistance. So if that's the case, you might have another column here. And this column should be one, it means the reciprocal of what? Of resistance. Right? So it means that if you can compute it, you have 1 over R1, 1 over R2, 1 over R3, and 1 over R4. So when you draw the graph, because we are not asking to sketch, there's a difference between sketch and draw. So draw, you have to use a scale. Okay? If you do remember that we used it to teach you that. Here you have to write the scale. And the scale is always horizontal scale and vertical scale. So you can have maybe 1 centimeter represents what? In horizontal scale. Represent what? Representing, let's say 2 muho. Means that per ohm. Because this is the reciprocal of resistance. Right? Maybe vertical scale, you can say that 1 centimeter. I'm just reminding you. I want to link with today's subject. 1 centimeter represents, let's say representing 1 ampere. So you can draw your graph, so you have something like this. Something like this. Then you can draw your graph, let's say that your graph is a straight line like this. Are we together? I'm just reminding practical science. Then I will take you to practical electronics. Are we together? Because the problem that we encounter as Tanzanian students and teachers, we used to forget the previous materials. Okay? So once we draw the graph, then the next question, if you do remember, you'll be asked to find the slope. Isn't it? Eh? And you know the slope, how to find the slope? We taught you in coordinate geometry. So here we are going to have what? Change in current. Then here we have change in what? This we call it 1 over resistance, we call it conductance. Isn't it? Conductance is the reciprocal of 40. So it means change in current over change in what? Okay? So we used it to calculate slope. Slope is equal to change in current over change in what? Conductance. Are we together? Are we together? Then if you do remember that, the next part of the question is you will be asked that maybe determine what? Determine once you have a slope, you have to record maybe Ohm's law, we say that voltage is equal to current times resistance. But here that we can make resistance the subject. So determine, let's say, for example, voltage. So it means that we can have I is equal to what? V over R. Right? If you do remember, we used to compare this one with MXC plus C, the linear equation. Okay? So for this case, I've just took roughly. It means it's not a particular set. So it means that for this case, the y-intercept, it means y-intercept is 0. But if you write this one, we have I is equal to what? V, then what? 1 over R. So if this is equation 1, this is equation 1, and this is equation 2. If you compare equation 1 and equation 2, then you find that slope is equal to voltage. So slope, actually in case of electrical, it's electrical property. It's a particular electrical, but that particular electrical property is represented mathematically. Are we together? Do you remember this stuff? I know that you are expert. Right? I know that you are expert in this stuff, dealing with this one. And especially when we went for advanced education, we were learning some techniques to forge. And I have been teaching that for more than 5 years. So I remember all of those steps. And I've been teaching my students how to solve or how to do practical questions, physics problems of more than 30 questions, 30 experiments. And actually we can fill that table without doing an experiment. I think you remember that. Right? So the same scenario that you've been teaching you in science, it's the same scenario that we have in electronics engineering. Are we together? So you see that you've been dealing with numbers. Here we have numbers. This is numbers in science, right? And also we required or we recalled the Ohm's law. So formula. Here it's a formula. Okay? Okay? And then we say the number 2, diagrams. So diagrams, in case of mechanics or electrical, or we say that heat, or for those who are doing light in O level, we are not allowed, it means that the diagrams is drawing on the question paper. Okay? We are not asked you to draw the diagrams of that particular experiment. Okay? Then we came to tables. Tables, this is what we have been feeling. So this is what we call practical science. So if you are doing an experiment and you don't have any table for results, it means that that is not a practical experiment. That is actual, you are trying to make politics in engineering. If example that you say, today I'm going to do an experiment to turn on a light emitting diode. We expect you to come up with a table of results. We expect you to come up with what? A graph. So from there, we know that you spoke as a scientist or as an engineer. Otherwise, you are a political engineer. That's a little bit bad news. So ask your neighbor, since you came to DIT up to now, how many graphs did you draw? Ask your neighbor, since you came to DIT up to now, how many tables of results did you draw? You used to go in practical, isn't it? You used to go to do practical, isn't it? So where are the table of results? Ask your neighbor, where is your table of results? So the answer is your neighbor is getting prepared to be a political, electronics and telecommunication what? I didn't say, it's your neighbor who said that. Are we together? Yes. So the good thing that we have in practical electronics or in practical telecommunication engineering, this is the concept we taught you. With this concept, if you do remember, we have to teach you theory first. And then you do practical. Right? So the good thing for the electronics, whenever we want to solve any particular problem, we have to find the theories relating to that particular problem. Second, we have to find the simulation technique and simulation tools relating to that particular problem. And thirdly, we have to do the hardware implementation. So in science, we had only 2 parts, theory and practical. In electronics and telecommunication engineering, we are going to have 3, theory, simulation, and practical. Ask your neighbor, did you understand? Ask your neighbor, did you understand? So this is scientific table of results, for instance. So that's why we are teaching you mathematics. And that's why mathematics is the queen of engineering, because we need it. So then, if this is the case, just let me take, or let us observe this table of results, which is not new for us. We used it, we learned it during our O-level education and during our A-level education. So how can we now do the same practical maths, but not in the context of science, but in the context of engineers? This is how we do. We have a table. How many columns do we have? 4. So it means that if now I want to draw the same table, it means I want to do that practical with the image of engineer, then I'm going to have a very interesting table of result. Table 40. Table of results. I'm telling you the truth about electronics and telecommunication engineering worldwide. So it's a matter of you. So listen, stop writing. Look on the blackboard. Stop writing. So this will be our first column. Here will be, I will have another second column. And here we'll have another third column. So listen. These 3 columns will represent what? We represent only the first column of resistor. The first column of resistor. And then this one. So stop writing. So we know that we have Ohm's law. And Ohm's law can help us to do theoretical calculations or theoretical computation about voltage, current, and resistance. So that's the theme of Ohm's law or Ohm's equation. Are we together? Are we together? So, now practically we say that we will need the value of resistor, but we call it what? Theoretical resistor, which is come from computation or calculation, or come from the use of the formulas. Okay? The next column, we are going to have the value of resistance, but according to the simulation software. Are we together? Yes. Are we together? Yes. The next column will have the values of resistance, but this is practical resistance. So I have again another column. It's the same process for what? For voltage. Same case for the voltage. So here we have what? V1. So you're going to have theoretical voltage. And then so you're going to have voltage, simulated voltage. And then so you're going to have practical voltage. I think you see now how business becomes interesting. Tell your neighbor, do you see how business becomes interesting? Then we have another column for current. So we are going to have theoretical current or computation current. And then we should have another column of simulated current. And also we should have another column of 40 practical current. Then, here again we have another column of conductance. So for the conductance, we should have conductance, theoretical or computational conductance. This is just a use notations of T. And then we should have conductance based on the simulation software, 1 RRS. We can also have conductance which we measure it practically. So how many columns do we have? 9, even counting number of columns. 12 columns. But these 12 columns have been deduced from how many columns? That's all about engineering. So you as electronics and electronics engineer, whenever you sleep, whenever you wake up, you have to think about table result. Otherwise, you are speaking politics. In our country, we have so many political electronics and telecommunication engineers. So what does it mean? So it means that the value of resistance 1 might be different from the value of resistance 1 in simulation. Okay? Might be also difference when you do or you measure the resistance of the resistor practically. This just took a simple context of resistors, or resistance, current, and voltage. We know that we have a ohmmeter to measure resistance, right? So how can we, for example, that know the theoretical value of resistor? We may use the, we call it the data sheet of the manufacturer, or we may use the color code. Are we together? So we may use the color code. If, for example, I gave you 4 resistors, and then I ask you to do the practice of it, I expect you to have 3 columns and 4 rows. So the first column, you may use the color code to calculate the value of 40, resistance 1. The second column, you may use any online or offline electronic simulation software, and you may use the ohmmeter, because we have software ohmmeter, to measure the value of resistor that we gave you. Then you write its value here. Then you may take a physical ohmmeter and measure the value of resistor for the resistance, value of resistance for the resistor that we gave you. Class, are we together? Yes. Are we together? Yes. So from there, it means that if now I take you, if you know the value, the theoretical value of resistor, and you know the simulated value of resistor, if I give a resistor and a physical ohmmeter, I don't need to come and tell you that that is the true value of resistance of that resistor. Why? Because you have an idea from the calculation, you have an idea from the simulation. So you can confirm yourself whether the measurement of resistor practically is correct or not correct. It's just like when you have been asked to determine acceleration due to what? Gravity. You know it's 9.8 or 10 meters per second square. If you do experiment and you find that acceleration gravity is 2 meters per second square, do you need your teacher to tell you that you are wrong? Eh? That's how. So I want to tell you that, you know that you yourself as, you know, you said, I like to do practicals. Okay. Doing practicals is not a problem. Do you understand what you want to do? And you want to skip from theories. You want to skip from simulation. My dear brother and sister, I want to tell you that electronics does not sing its song like that. What does it mean? You have so many informations to use. But you are waiting practical, you are waiting practical, you are waiting practical. Class, are we together? Yes. So the same scenario for RR2, the same scenario for RR2 in simulations and RR2 practical. The same scenario for RR3, the same scenario for RR3, the same scenario for RR, this one. So the same scenario for RR4, the same scenario for RR4, the same scenario for RR4, RR4 but in practical color. This is RR4 and this is RR4. Get it? Are we together? Yes. Are we together? Yes. So this is the beauty. When you learn electronics engineering and telecommunication engineering in this style, you will enjoy. And your designs will always work perfectly because you know what you are doing. And in case it does not work, you know the reason why. Are we together? Yes. So if this is the scenario, I wonder that I expect that every student is drawing this table now, but I wonder some of you are getting surprised. I told you from the beginning, today I'm going to teach you differently. So for you, you are still surprised. Is this Olenjolai we know, or this the other one? Okay. Because you imagine, you used always to assume that you know me. I want to tell you that you don't know me. Class, are we together? So whenever you want to solve any real life problem, you have to think about its theory, how you can simulate, and how you can do practical. You may be having a barrier. I don't have electronics components. I don't have a workshop. No. You can have a workshop, you can have all electronics components, but you do nothing. Because whenever you do, you then get result. And it is true. You have been going to W15-1 or W15-2. You do the experiment from morning to afternoon, no result. So at the end of the experiments, you ask, collect my stuff. You collect the stuff and then you leave. You are happy. You are waiting another experiment. Okay, so if that's the case, let me state the problem. Then we say that algorithm of solving a real life engineering or electronics electronics, engineering, or telecommunication problem is this. Let me remind you. The key for any solution is identification of the problem. Stop writing. Listen. The key for any solution is identification of the problem. We need a problem first. You have a computer that you have because it's an answer of the particular problem. Even yourself, you came into this world because you are an answer of the particular and unique problem. And I wonder, I don't know if you know, what problem did you come to solve in this world? Ask your neighbor, do you know what problems you come to solve in this world? Because for me, the one problem that I came to solve is teaching. Ask your neighbor, how about you? What problem have you ever solved? And what problems are you solving now? Are you solving problems or you are creating problems? Okay, so this is the algorithm. Algorithms, actually, we call that it's a set of procedures. Stop writing, stop laughing, look on the blackboard. So we used to say that we have 7 steps of solving any scientific problem. Do you remember them? The first one, identification of the problem. The second one, hypothesis formulation. The third one, experimentation. The fourth one, data collection. The fourth one, the fifth one, data analysis. The sixth one, data interpretation. The last, where did you apply those 7 steps in solving a real life problem? Ask your neighbor. You are a scientist. You learn science up to Form 6. You learned science for almost more than 10 years. What problem did you solve? Okay, so even in electronics and telecommunication engineering, the first step, we have to identify what? Identify what? Identify what? Identify what? And that's what I tested you in test 1. State the problem about ventilation system in W15-4. Do you remember what did you state? Your statement is very surprising. That is number 1. Then the number 2, we say that it's a process formulation. A process formulation is actually, it means you propose the solution. So in engineering, we say that we call it propose the solution. Propose the solution or propose the idea. I said stop writing, stop focusing what is going on outside, focus here. Say propose the solution. Then the next step, I told you that when you have a proposed solution, we engineers, we used to present our proposed solution by using diagrams. Are we together? Yes. Then we come for the diagrams. The fundamental diagrams is high architecture diagrams, which we call it general block diagram. You have to draw what? The general block diagram. Then the next step, you are writing. Now you are writing as I start drawing. Okay. I used always to repeat this stuff. And then you say, I understand. But last weekend, I tested what you have understood. And even yourself, you realize that you understood none. Okay. So this is the general. So the general block diagrams actual give you the general overview or general idea. Okay? And this is the point where I taught you about the 4 common blocks in any electronics engineering system. The power supply unit, the input unit, the control unit, and the output unit. Those are as generality. Those are general block. Then once we have these general block diagrams, we have to open or we have to specialize according to the problem. Then we get another type of diagram which we call it detailed block diagram. We call it detailed what? Class detailed what? So the detailed block diagram is more specific according to the problem that you are solving. And you remember in test 1, I asked you to draw the detailed block. And then most of you have drawn the general block. And all of you say, you know, sir, we understand you so much. We understand, sir. So, for example, the detailed block diagrams is what? Instead of writing input unit, for instance, if you want to solve a problems about temperature or about hotness in particular place, right? So it means the input unit, you should have a temperature sensor. So you will do drawing a diagrams, but in the input or in the block of input, you won't write input unit anymore. You'll be writing temperature sensor, or you may write it sensing unit. Are we together? Okay. Then, remember that we just use rectangles, others they are using cycles to draw the block diagram. Others we are using what? In this class. So we use cycles, rectangles, and the arrows to draw general block diagram. Okay? Then we use also rectangles, and we call them blocks, and the arrows, which we call them the flow of electric signal, to draw the detailed block diagram. Are we together? Those are the principles. Then, from here, once we have a detailed block diagrams, then now it comes for the business of engineer. And the business of the main goal of engineer, or the main task of any electronics and telecommunication engineer, is to design. So designing now come to place. And you know how design is going to come to place? You have to open those blocks and convert them into electronic schematic circuit symbols. So the next block will be schematic circuit diagram. So in order to move from the detailed block diagram to schematic, I said stop writing and stop drawing. I taught you to use this concept more than twice. And then when I checked your work, you didn't understand what I taught you. And you were writing and you read, but you didn't understand. Why? Because I explain a lot more than what I write. So this is schematic circuit diagram. To move, it means that actually that the step that you have to follow as engineer from the detailed block diagrams to the schematic circuit diagram, here it's a point that we call to design. Which it is difficult, I told you, to find engineers or to find teachers or lecturers or assistant lecturers teach you how to design. That's why I told you that the world of today, we have so many schematic circuit diagrams rather than block diagram. So this schematic circuit diagrams has been designed by somebody, but he or she does not reveal the way he or she has designed. He just gives you the final design. So to draw the schematic circuit diagram, because this is where we find for us number 3, diagrams. Right? We say that when we have these schematic circuit diagrams, we draw them by using electronics. I'm adding some key points. Electronics, we call them electronics schematic symbols. Say electronic schematic symbols. That's what we use to draw the schematic circuit diagram. Whether it is schematic analog circuit diagram or schematic logic circuit diagram. So you as engineer, you have to know all the schematic symbols of different electronics and electrical and the communications or telecommunication components. And if you want to know that you are ignorant in that aspect, you don't know even the symbol of the fan. You know what you drew to represent the fan in W154? Do you know? Some of you? Some of you drew something like this. So they drew the propeller. So this is the schematic symbol of what? Of the fan. And this concept we taught you in general chemistry. We call it dipole moment. So we are drawing dipole moment. I know you forgot, but for me I remember because I love them. Do you remember dipole moment? We used to draw them in what? In chemical bonding. And then we used to write that this is partially positive and this is partially negative. Ha 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 ha. Hey, you are PCM by nature. Eh? So chemistry is your enemy. Eh? Chemistry for the PCB. Okay, keep it up. So this is the schematic symbol of what? Of the fan. But somebody can find that, say, okay, let me just draw the intelligent one. So this is the fan. And here there's electrical wire, and here there's another electrical wire. So simply, you are still ignorant. You know some schematic symbols of some electronics component. But for those that you have never dealt with them in primary and secondary, you don't know them. So the only way, you have to find them. And the good thing that, because I'm teaching electronics drawing, so I used to teach my students a number of schematic circuit diagrams. If you don't know schematic circuit diagram, it will be difficult for you to draw the schematic circuit diagram. If you don't know how to design, it's difficult for you to develop your own schematic circuit diagram. You'll be looking online, you'll be looking in the books, the schematic circuit diagrams which has been designed by other people, absorb, implement. And you call yourself a chief engineer of electronics in what? In Samandito's family. Are we together? Then the next step here in our design, once we have the schematic circuit diagram, we can go to simulation. And in case of simulation, also you can also write sometimes with computer program, in case that that system needs what? Need computer program. Then the next step now, we go for, we call it hardware implementation. So we go for what? Hardware. Hardware what? Hardware what? Hardware what? Hardware implementation. That's what we find practical. So for you, you want to skip all of this step and go for W15-1 and 2 and do practical. Practical for what? Ask your neighbor, practical for what? You don't know the problem that you are solving. You don't know the proposed solution. You don't know the general block diagrams of that system. You don't know the detailed block diagrams of that system. You don't know, you just have schematic circuit diagram. You don't know where it has been found or it has been designed. You just have a finished schematic circuit diagram you want to implement on the breadboard. And we say, okay, that's what you want, we give you. But expect you to do a change and contributions in this world. Are we together? Yes. Are we together? Yes. Yaani mnachosema bwana wiki ya 11 tujafanya practical na nasi okay fine, hamna shida. Ndio maana kwamba kinania okay naye mwalimu anakuja anapeleka. Hujui tatizo, you don't know problems, you don't know anything else, you don't bother. Just schematic circuit diagram, go for simulation. Then one simulation, go for hardware implementation. Okay. You have to skip all of this stuff and expect them to be as a miracle. So you'll never be able to solve problems. Are we together? Yes. That's the truth. I'm telling you the truth. Whether you like or you don't like. And I'm not talking about somebody else. I'm talking about the truth that we have. Are we together? Yes. Yes. Then the next step now, we go for results. It means testing, and what? So I say testing and the results. Then the last step, we go for conclusion. We go for what? Conclusion. If you have understood this algorithm, tell me in this process, where are you going to get this theoretical data for a particular system? In which point are you going to get theoretical data for the particular system? Class, did you understand what I told you? Did you understand what I told you or you didn't understand so that I can repeat? Did you understand what I've been teaching you? Did you understand this algorithm or you didn't understand? You understood. So tell me, for instance, if I'm solving a problem of maybe high currents and I want to use the resistor, where will I get the value of theoretical resistor in this algorithm? Where? Propose the solution. Wrong. Where will I get the result, the theoretical result, or calculation results, or calculation values? Where in this in step number 1, number 2, number 3, 4, 5, 6, 7, 8, 9. Eh? It is difficulty question for you who have been seeking for the maxi to pass exam. But for those who have been seeking skills first, and then maxi come next, it's very simple to answer. The answer is there. The point where we'll get the calculation, or the calculated values, or the theoretical values of any electrical parameter. Look your neighbor. I'm explaining something. Look your friends there. They are busy. Look the backbencher. They are busy. When I will give them the same questions in the test, they will fail. And they say that we are not told. In the class, they are chatting. So class, I say that whenever you want to sound as a practical electronics or telecommunication engineer, in any electrical parameter that you are going to measure or you are going to deal with, we need 3 columns. We need the calculated value for that electrical parameters. That's why we have mathematics and formulas. We need the simulated values for that particular parameter. And we need the practical values. Okay? So the question, if I have a table, if I have a column of V, theoretical voltage, and this is the process I want to follow, in which steps that I can fill this table. I can fill these cells. In which step? Huh? Huh? Speak loudly. You don't trust yourself. You have lost your confidence. The answer that we will only get these theoretical values of voltage or calculated values of voltage in this is between this step and this step. So we'll get all of those calculations or all of those calculated values during the design. During what? And we have been teaching you design in advanced electronic science, in advanced electrical science. When you've been learning about what electrical science, we have been teaching you design. Because we have been teaching how to compute different electric parameters. Right? When you've been teaching about AC theory, we've been teaching you how to design. But the problem is to transform that knowledge into what? So this is the point at where we get what? The calculated values. Right? And then this is the stage where we'll get what? The simulated results. And this is the step where we'll get what? The practical values. So this will be the first column. This one. We'll fill the first column. Shukuru is outside of the class. This one will fill the second column. And this one will fill the third column. Are we together? Yes. Always you say yes. Do you have any question? Is this session interesting for you? Huh? Is this session interesting for 90% or 10%? Eh? Ask your neighbor. Is this session interesting for 90% or 10%? But before you answer that question, ask you, where are you? Are you in 90 or in 10%? You don't want to ask your neighbor because you know the answer. So listen. So if we have this algorithm, if you have that algorithm, now we have to follow. Or we have to, I want now to take one problem where we will follow or will be solving that problem by following at least some few steps that I have listed in this algorithm. Brighton, you are disturbing Adam. And I have been patient for a long time. Wait, when I finish the class, we'll have your discussion the whole day. So, let us say, number one, we said what? So let us practice what I've said. Are you ready for that? Yes. Let us practice what we have learnt here. Let us take one problem as one of our electronics products. Then let us follow that algorithm step by step until we see the final product. And then you know what are you going to do? You will do for your 10 what? Do you remember them? 10 what? Schematic circuit? You are silent here. You lost them. Okay. Shukuru say, sir, don't mention it anymore. Okay. So number 1, we say that identification of the problem. Or sometimes in engineering, this sentence, we just call it a problem statement. Say problem statement. So state the problem that you want to solve. Problem statement. So we say that this is the problem statement. We say that it has been observed that the audio, or we call it, the audio signal for public address attenuate after long distance of transmission. So this is the problem. I want, or if you want sobriety, if you wanted to do public address, say public address. Public address means that you wanted to provide a speech, maybe to 1,000 people, right? Maybe in a particular ground, for example, a football ground. So those 100 people who have gathered together, you cannot reach them by just speaking by using your mouth. Okay? So you need the way that, where the technology can help you to receive your small or your low signal, you call it just your low signal, your low voice signal, in order to reach 1,000 people gathered in a particular ground. So why can you deliver the message to 1,000 people who have gathered in a particular football ground? It's because when I speak, the signal that I'm speaking, it gets attenuated. Its energy gets decreased as it travels to the long distance. That's why right now, if I speak, a person who is passing outside of this building cannot hear what I'm saying. But in case that I have just a microphones, and I have maybe some amplifiers, and then I have a speaker or a loudspeaker, I can use the same, or I can speak with the same strengths of the voice, of the sound, but even other people away from this place, they can hear what I'm saying. Are we together? Are we together? So the problem is attenuation of 40, audio, attenuations of 40. Remember that in electronics and telecommunication, we have amplification and we have attenuation. Amplification is boosting up. Attenuation is reducing, is boosting down. Are we together? Yes. Have you ever heard them? No, you just said amplification. But attenuation, you have never heard about that. And amplifications and attenuation, do you know how do you represent in electronics? We represent this by using decibel. Say decibel. Yes. In short, we call them dB. And you used to see them in case that you have a subwoofer. But you don't bother yourself. Why? Those are European stuff. None of your business. Okay? So this is the problem statement. Say problem statement. It has been observed that the audio signal for public address attenuate after long distance of transmission. Simple like that. That's a problem. Okay? Okay? Then we go. Number 2. I've said it the problem. Did you understand my problem? Class, did you understand my problem? Huh? Yeah. Number 2. Number 2 is what there? Eh? What? What? Huh? Proposing solution. So we propose this solution. What do we say? Separating. This is my proposed solution. I say that. So if this is a problem, there is a need. There is a need to design an audio. To design an audio amplifier. To amplify the audio signal to overcome, okay, the audio signal, to amplify audio signal for public address. So this is what we call the proposed solution. Say proposed solution. Sometimes proposed solution we call it objective. And in electronics and telecommunication engineering, we have main objective and the specific objectives. We have what? Ask your neighbor, what is your main objective of studying a bachelor degree in electronics and telecommunication engineering at DIT? Ask him or her. First of all, do you have main objective to study here? That's the first question. Don't waste your time. Do you have the main objective to study here, or you are here accidentally? Eh? Class, I'm talking to you. What did your neighbor say? He is here or she is here accidentally. Okay, you are welcome. The accidentally student, engineering student, you are warmly welcome. We are here to save you. You don't have alternative. Whether to drink a cup or to leave it. Precious it is enough. Okay, so this is the proposed. So you see the proposed solutions is just the one sentence. And should be clear. There is what? Because there is a problems of communicating the message, the audio signal to the public address, then we have to design the amplifier that will boost the audio. Eh? So this we call the main objective. We developed a specific objective from the detailed block diagram. Eh? Hi. Number three. Number three is what? Eh? Hi. General block. General block what? Huh? 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 Ask your neighbor, what is general block diagram? Ask your neighbor, what is general block diagram? I have just defined block diagram in general. I did not define or give you definition for the general block. I did not also give you the definition for the detailed block. And you have never asked me. So I assume that you know. So now let your friend ask you if you really know or you don't know. Zuena, ask your neighbor. This is your neighbor, that's your neighbor. You see your neighbor is smiling? General block what? So remember that the audio amplifier, it's an electronic system and also it's a communication system. Let me repeat. Remember that the audio amplifier, it's electronic system and also it's communication or telecommunication system. What does it mean? In most communication system, we find amplifiers. In most electronic system, we find amplifiers. So amplifier is not limited for only electronic system or for only telecommunication system. Are we together? Eh? So the general block diagram, first of all, an amplifier cannot work without power. Okay? Okay? Can your radio work without power? Eh? So the first general block, we call it power supply. Power supply what? Power supply unit. Then, this is the first fundamental block. The second fundamental block, which I told you, you should not bother yourself with a control unit if you don't have input unit. You should not bother yourself with the output unit while you didn't wait for the input unit. So an amplifier will need the input signal. And that input signal will be delivered in input unit. Are we together? That's what I expected you to think last Saturday. And we are actually saying that the time is enough for us to think. We have no any way of thinking again. Tanzania, Tanzania, our God, remember our country. So we must have the input unit. We don't know, or we don't have any idea that what are we going to use. But we should have that block. Peter, you are petering now. Okay, Peter is petering. Limi is limiling. And Lucy is loosing. So, when I have the input unit, which is audio signal from the audio source, okay? 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 Then that signal has to be amplified. So the control unit for our system is audio. So because it's general, it's amplified. Are we together? Yes. Then, once the signal, the audio signal or the signal is amplified, we expected another system, subsystem, or another device to receive the amplified signal. So it means that that device, which will be receiving the output signal from the amplifier, we call that unit output unit. Are we together? It's not a miracle. It's not a matter of being intelligent. It's just a matter of thinking. And God has given you intelligence to think. He has given you the brain to think, but you don't want to use it for thinking. You just use it for complaining. The output what? Are we together? Listen. I say listen. So we say that now we are going to supply power. So the input unit, you should have an idea of what are we going to do. The input unity for our audio signal, especially for the public address, we expect it to use a microphone. And the microphone, it cannot work without power. And the power for the most of wireless microphone is battery. And if you just want to know, for instance, this is the simple wireless microphone pill. So if you open at the back, you'll see that these are the batteries. So this is the source of power. Are we together? Are we together? Yeah. But for you, you're just drawing arrows without understanding. Why? You say, I am a beginner. The first week, you are a beginner. The 11th week, you are still what? Until you graduate, you are still what? So then, but also the amplifier will need what? The power. Because we expect you to use either transistor or either operation amplifier. So because we know that this is the semiconductor devices, they cannot work without power. That's what we used to teach you theoretically, over and over. Okay? Okay? So it means that also here we are going to have power supply to our input unit. The power supply might be the same or might be two different sources. For instance, the power supply for the video camera that I'm using right now is different from the power supply that I'm using in this microphone. Are we together? But when we draw as a general idea, this DC source and that AC source, but there's adapter that converts into DC source, but the DC source of the different values Together we call them power supply unit. Are we together? Then the output unit, because I want to communicate with the public address, the output unit will need what? So the output unit in most of the cases for the public address, it will be a speaker. It will be what? So it depends. Sometimes you can have a standalone speaker, or you can have AC speakers. When you say that the standalone speakers, you find that sometimes you find some speakers, they have built-in battery that we can charge them. Okay? So because you are still general, you didn't specify, you say even the output unit might need what? The source of power. Remember that this is design. You are allowed to do adjustment in case you find that some things that we are thinking about, they are not working. Are we together? Are we together? Then this is all about, we call them, I told you that this we call power signal. And this we call power signal. But you don't work on what I told you. You're working with something else. Then, here in the input unit, we expect that the input unit will provide the signal into the amplifier. And the amplifier, once it's amplified, the signal will provide the signal to the output unit. Are we together? Yes. So then, ladies and gentlemen, this is figure 1. And I have to label. This is the general block diagram. General block diagram of audio or small signal audio amplifier. Audio what? Audio what? Audio what? Number 4. Go to algorithm. Number 4 is what? Detailed what? Draw. Say that, oh, I had this block. Okay. Detailed what? Block. Detailed block diagram. Which I asked you in test 1. And possibly you have complained extremely that this person has never taught us anything about detailed what? Block diagram. But I taught you 5 weeks ago. But because you used to forget and don't care, okay, can conclude that we didn't learn. You are sharing a pencil, engineers. Where is my exercise? Where is my exercise for writing names? So detail the block diagrams, we say that, simply here we say that, we say that, you can say that, so simply we say that here, draw the specific block diagram according to the proposed solution. According to the proposed what? Solution. So I don't want to speak a lot. I just want to do what? Just want to draw and speak. Speak the engineering language. So remember that. Hey, listen. Remember that this is output of the input unit. And this is input of the amplifier. The output of the input unit and the input of the amplifier must have or must speak the same language in order for them to interface. Did you understand what I said? No. Let me repeat. I said this one represents what? Represent the output of the input unit. Okay? And this one represents the input of the amplifier. Pencil, rubber, you are just borrowing. And then you say to yourself, you are engineer. A serious? Or a gifted? Or engineer by calling? Okay, so we say that in order for the output of the input unit to interface with the input of the amplifier unit, they must speak the same language. Do you understand? For instance, if you have a USB port in your computer and you have a flash, in order for your computer to interface with the flash, they must speak the same language in terms of hardware and in terms of software. Do you understand? If they are not compatible, there is no exchange of files from your computer to the flash. Are we together? Are we together? Okay. So now, depends according to my design, the place where I want to do my public address, there is a source of electric or alternating current. So there's a source of AC, or we call it domestic power. That is, I can get, or I have to go to the site to study some supporting or conducive environment in order to make sure that I achieve the goal. Okay? Okay? So that's one thing. So if there is a source of electric current, there is no need for me to add designing cost to think about another source of power. It's better if I use the available resource. Okay? So for that case, I have to think as engineer, how can I convert, because I will have an amplifier which will be using the direct current, but the available source is alternating current. So I have to think as engineer, how can I use available resource? Well, I have to learn and I have to think, how can I convert alternating current into direct current? So for that case, I have two options, whether I might use a linear power supply or a switched mode power supply. Okay? Okay, so the simplest one that we teach students is linear power supply. Later on, we can teach you about switched mode power supply, because the switched mode power supply, actually it uses some advanced discrete electronics components such as MOSFET, which I know that for your level and your speed of learning electronics, possibly you know anything about MOSFET. Maybe you know the definition, you know the symbol, you know maybe to do simple analysis, that's all. Because you have been learning about bipolar junction transistor since you are in what, Form 5? Because you used to learn electronics in December. So this is the time for learning electronics for those Form 5 students who are going for the what? So you learned since what, December, you are what? Form 5. Right? Up to today, I want to tell you that you don't know bipolar junction transistor. And even myself, I don't know the bipolar junction. So if you don't know what you met 3 years ago, do you think that you could know what you met 3 weeks ago? Zuena said yes. Zuena Sunzu. So here, I'm drawing the detailed block what? Eh? Stand up the whole class. I say stand up. Every student stand up. Even the backbenchers. Take a time to stretch yourself. You were extremely tired while I didn't start to teach you. Okay, have your seat. You always were tired. Morning you are tired. Afternoon you are tired. Evening you are tired. Night you are tired. Always, in case of studies, you are tired. We call it you are tired by default. Hey, do you understand what am I teaching you? Yes. Okay, congratulate yourself for understanding up to this level. So 1, 2, 3, let us go. Hongera. Imara. Wow. Yes. For understanding up that stage. This is tough and not simple. You said, This stuff is simple. Linear power supply. Linear power. Linear power supply unit. I'm specific now. Linear power supply unit. Writing linear power supply unit is completely different from power supply unit. Because I can use DC power supply unit. I can use, I can use it. I can use it, solar power supply unit. So I have different option here. Okay? Hey. Then I have the input unit. Okay? So in case of the input unit, because I need just to capture the audio signal. So if I need to capture the audio signal, the input unit, I will just have the microphone as a separate component. Then I will have what? I will have the amplifier or the control unit as an amplifier. But the amplifier, we have different types amplifiers in electronics and communication. We have what? Of what? So each type of amplifier has its way of designing and have its way of just arranging the components and having its way of testing. We have audio amplifier, we have power amplifier, we have radio frequency amplifier, we have video amplifier, we have microwave amplifiers, we have, yes, we have different types of amplifiers. Okay? Okay, we have intermediate frequency amplifier. So we have so many amplifiers. So in detailed block diagrams, you have to narrow. Because intermediate frequency amplifier is not the audio amplifier. And the audio amplifier is not the power amplifier. And the power amplifier is not the, what? The video amplifier. Are we together? Okay, yes sir, yes sir, yes sir. Always you are telling me, yes sir, yes sir, yes sir, yes sir. But when I ask you a question, then your answer is no sir, 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 no, no sir. Sir, you want to kill us. Sir want to kill us. Because I met some students who say, real sir, is there any students who will get A in your subject? So those are the questions of what? We call them maxi seekers. Audio what? The first priority is to get A. While the first priority is competence-based. Your first priority is to get A or to get first class. But the first priority of the Dar es Salaam Institute of Technology is competence-based. Is skills first, then passing follow. But for you, you reverse. Okay, I'm speaking a little bit difficult that language, yeah? Ask your neighbor, do you have peace? Then we are going for output unit. So when this audio signal is being amplified, we have to feed it in the output unit. And at the output unit, because we want to do the public address, we are specifying it. It's a speaker. Okay? This, I say, listen first, listen, understand. I told you this is stuff. And you saw, and you wrote them. But when you have been doing the revision, you realize that you didn't understand. So the audio amplifier needs power, and especially DC power. And the microphones also needs power in order for it to work. The microphone needs power in order for it to work. And I showed you example. The speaker also, sometimes some of the speakers needs also electric power. Some of the speakers. Some of them, they just need electrical signal. Are we together? Then, the microphone, when the microphone receives the audio signal from the human being or from the speaker, it's actually that conveys the mechanical signal into electrical signal. Then this is its representation. Because remember that I told you that this is data signal. And this is data signal. And you just do it, then you end it there. You are waiting for me to speak another story. But you have never gone and find different block diagrams and analyze them. Why? It's not your interest. Okay, so this is audio. This, remember that the microphones receive mechanical signal. For instance, this microphone, it receives mechanical signal, which is rarefaction and the compression. We learned in wave as a first topic of physics from 4. We have rarefaction and the that's all. It's mechanical wave. It's not electromagnetic wave. I cannot produce mechanical electromagnetic waves. What I'm producing, mechanical. So the microphone, this we call it, it's a transducer. Convey the mechanical signal into electrical signal. So this is what? Audio signal. Audio signal. In most cases, this is DC power signal. If you want to label to go too much detailed, this is DC power signal. If you want to understand electronics. Then once the audio amplifier amplifies the signal, deliver the signal to the what? To the speaker. This we call it amplified audio signal. This is an amplified audio signal. Digna. This we call it an amplified. Say an amplified. An amplified what? Eh? Here we are going to have what? Nikusaidie kwa sababu kwa kweli una hali mbaya. Una hali mbaya kwa sababu wewe unatakiwa ufikiri signal. Wewe unafikiria movie. So this is amplified audio signal. Amplified audio signal. This is an amplified audio signal. This is information signal and this is information signal. This is DC power signal. This is DC power signal. This is DC power signal. So this one is no longer general. It's specific. This one is general because you find the most general block diagrams for the amplifier is like this. Hello? Uh-huh. What did you understand? What didn't you understand? What did I label there? Everything is clear. So? Pardon? Then? The audio signal. What do you understand about the audio signal? Do you think that audio signal is only a mechanical signal? Eh? Audio signal, it means that the vocal signal, whether in mechanical form or in electrical form. Are we together? Are we together? So the process of converting, we just convert from one form of energy into another form of energy. But the information is still the same. Because we taught you in physics form 1, nowadays, previously we are studying physics form 2, that energy cannot be created nor destroyed, but it can be transformed from one form to another form. So when you come to engineering, we tell you that all electronics components or devices that convert energy from one form to another form, we call them transducers. Okay? Okay, brother? Welcome. Another question? Speak loudly, please. Yes. So did you hear the answer? Let me repeat. Don't be fixed-minded. You might be finding yourself that you wanted to find a way of framing the stuff. That when maybe you hear audio, you think that audio is only mechanical signal. So let me answer those two questions and take time to think about it. We say that the microphone receives the mechanical audio signal because we have different types of mechanical signal. Okay? Then, the microphone is a transducer. It conveys the audio signal into what? Electrical. So, we have different types of electrical signal. So, what the type of this electrical signal? It's audio signal because the source is audio. So that's why I wrote that. So the microphone receives audio signal or audio mechanical signal, convert it into an amplified audio signal. And when the amplifier, the amplifier is still amplifying audio electric signal. Amplifier cannot amplify audio or mechanical signal. Are we together? Are we together? Okay. You, get in. I see that, get in. Come and sit in. Hey. That is my friend who used to skip the class. The evening class. Get in. You want to stay there? Okay. Number what? Hey? You are lost here? Number 5. Huh? What is number 5? Eh? I'm talking to you, class. If you don't bother yourself, I can talk with online students. So you should not worry. God is giving me a number of students. So if, yes, you are majestically to speak, you should not worry. Number 5, I wrote that we have to draw the schematic circuit symbol, circuit diagram. So, when we have our detailed block diagram, from here we can analyze and we can think whether the large part of this system is analog or it's digital. So the large part of that system, of that design, is analog. So you're allowed even to say that schematic analog circuit diagram. Or in other words, we can say that schematic analog circuit diagram. Analog diagram. So we say that in order to draw the schematic circuit diagram from what? From the detailed block diagram, then we say then you have or you must open each block of the detailed block diagram. Because I told you that we always draw, stop writing. I told you in previous workshop or lectures, we always draw the schematic circuit diagram from the block diagram. And I told you that in your life of electronics, you will be exposed with a number or a lot or so many schematic circuit diagram rather than block diagram. And if you did your investigations or research, you have proved what I told you. You have so many schematic circuit diagram, but you don't know they are general and detailed what? Huh? Why? Because that is not a hidden knowledge. It's not a knowledge for everybody. So it means that according to the engineering standards, I'm doing a mistake to teach everybody about that hidden knowledge. Should be taught few people who are interested. Like you? Okay, she has smiled. Okay, so in order to draw the schematic circuit diagram from the detailed block code, hey, my dear student, you must see open. So these are the closed block diagram. These are the closed diagram. So you must see open each. And that the point on that the responsibility of engineer. Okay. And I know that now you're saying, okay, today we'll see, How teacher will open this block, how will it open this block? How teacher will open this block, I know that's what you are thinking about. And your target is me to fail to open those blocks. In order to say that, hey, umeona? You see? You see? He always asks us to open block diagram, but himself, he cannot even open one. Okay, clap your hands for what you are thinking. I know what you are thinking. Congratulate yourself. That you are wrong. That is good. To think like that is good because you will be challenging me. But the only thing you will be not challenging you to seek the knowledge, to let me fail. In order to prove that aliuziwa cheni ya bandia, yani aliuziwa cheni, kauziwa cheni ya bandia. Na aliyetoa hela ametoa hela ya tuliozoea bongo, tunasema hiyo ni ngoma. Kwa wewe unavyoamini kwamba mabloku huwa hayawezi kufunguka, ndio unavyoamini, si ndio? So you'll be trying to also to make sure that I come to your. Okay, so let us go to that business. So we have to open this block. 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 If you remember the algorithm that I gave you, what are we using to draw the schematic circuit diagram? Class, I'm asking you a question. If you refer the algorithm of solving a real-life electronics or telecommunication engineering problem, what are we using to draw the schematic circuit diagram? Speak loudly. This side, nobody who have spoken. What are we using? So you have to come up with the schematic symbols that used it to design this. You have to come up with the schematic symbols that we get after opening this block, similarly to this block, similarly to this block. Are we together? And to open this block sometimes might be involving mathematical equation, mathematical derivation, and might be involving calculation. And that's the point that we apply mathematics in engineering. So let us open the fundamental block. So throughout this topic, or chapter 4, solving a real-life electronics engineering problems, I will be opening one block after the other one. Okay? And we'll have the schematic circuit diagram. And then we'll take the schematic circuit diagram, we'll go to the next step, we'll simulate. And then if time will give us a chance, but I'm not limited with time. Even after time, we'll go and build it that schematic circuit diagrams in hardware implementation and see what will happen. Okay? Yes. That is where I'm going. I don't know you. Where are you going? Ask your neighbor. Where are we going? Where are you going? Are you going to the same destination of the teacher, or you want it to drop? Okay. So now this is the fundamental. Fundamental. Okay, this is the fundamental. Okay. But this is the one of the fundamental, because you can see that it's being depended by all the three blocks. So if you don't have power supply, this block might not work, this one might not work, this one might not work. Won't understand that? So now, 5.1, open the block of linear power supply. Linear power supply unit. So let us open. I know that possibly you've been learning about linear power supply, but I want to tell you that there are some information possibly you have never heard it. So when I'm teaching about how we can design a linear power supply, don't limit yourself that I know everything. I want to tell you that until I finish to open this block, you will have so many important and practical information more than you think. Are we together? Yes. Are we together? Are we together, class? Yes, sir. But you can say that, okay, I know. It's fine. So, in order to open this block of linear power supply, we must begin from the beginning to the end. Are we together? Eh? So we say that the first step, we say that draw other blocks or draw the detailed block diagram of a linear power supply unit. This is electronics product fabrication. And you should not worry about PCB whatever. You have another module that will be studying in your third year, which is called the electronics product fabrication. So I will take you from one point to another point, and somebody will receive you from there. But I know your prayer. Will you pray that so I will teach you that same module? The first step, I read the first step. Draw what? Have your seat. Draw what? This is a detailed block diagrams of 40 audio amplifier. It's not a detailed block diagrams of 40 of linear power supply unit. You see, I told you that a block, one block, might consist 2 or 3 or 4 or 5 or 6 other blocks. So before you think about schematic, open first the blocks. Hey. 8 student, 8 engineering student. Okay. So with this linear power supply, always we start from the source. We start from the source. Yes, Ka, we are still in class. So the source of linear power supply, the source of power, will be the AC. We call it AC mains. AC mains. Then these AC mains will be fed. To one of the important block. So let me reduce the size of this block because of the space that I have. And this block, because the AC main is the standard for Tanzania's electricity is 240, is actually 220 to 240 volt. So this is alternating voltage. So this one, to convey it 220 volt, I say this stop writing, we are drawing the detailed block diagrams of linear power supply unit itself. Okay? So we say that to convey it, or maybe to take, to convey it 220 volt or 240 volt into DC is not effective in electronics component. Can I repeat? Can I repeat? Yes. For instance, for you as a teenager, it's not effective if now your father or mother give you 1 billion. Because if you have 1 billion, first of all, you will tell DIT, bye. And then sometimes you can go and kill somebody. Say that I can kill you and pay you. I can kill you and then I will pay your parents. How much do you want me to pay you? Okay? Okay? Sometimes you can take just your dinner in South Africa. Yes, you are going to South Africa, not for the particular issue is just to take dinner. So you can see that if your parent or your guardians give you 1 billion, it's not effective, isn't it? Why? Because it's a lot amount of money rather than your thinking capacity. So right now, you are not in positions of owning what? 1 billion Tanzania shillings. That's why that right now, you are owning what? 10,000, 100,000, or 500,000 of the boom, or 1 million, or maybe maximum, you might find up to 10 million. Because you can remember that, what did you do when you get your first boom? Do you remember that night, how was it? First of all, you went to where? Which hotel? Eh? So, this domestic voltage is high to convert it to DC. To have a DC of more than 30 volts, it's dangerous. So we have to step it down. Right? We have to step it because DC, we cannot, the maximum DC voltage in electronics is 30 volts. Rather than that one, it's dangerous more than AC. So if you have a DC of 240 volts, in case you do a mistake and then you get a shock from it, you might paralyze. DC NH in high voltage is dangerous more than AC voltage. So here we need to step it. So in order to step it, we taught you in electromagnetism that we have 2 types of transformer. We have step-up transformer and step-down. We have step-up transformer and step-down. And in electronics, we are using both. We are using step-down transformer for the in linear power supply, but we are using step-up transformer in case that we want to build the inverter. Aye. Step-down what? Step-down what class? Ask your neighbor, are you step-down transformer or step-up transformer? Are you stepping up electronics or stepping down? Same power. Then, so I will step down the voltage to the particular voltage. So so the standard step-down transformers in electronics that we have a 12 volt step-down transformer. We have a 9 volt step-down transformer. Then we have 24 volt step-down transformer. Yes, these are the common step-down transformers that you have. So this step-down transformer, it can step down 220 volts or 240 volts to either 12 AC voltage or 9 volt AC voltage or 24 AC voltage. Are we together? Are we together? Yeah. So step-down transformer, step AC voltage into AC voltage. Step-up transformer, step up AC voltage into AC voltage. Then, once we step down this AC voltage, we want it because our amplifier and microphone and also what the other parts of the output, they need DC voltage, direct current voltage, or direct current power. That if I stand up. So here, we are going to have something that we call rectifier. So this is the rectifier unit. And you know, we taught you in advanced electronic science that we have 3 types of rectifier. The first one, you forgot, half-wave rectifier. The second one, full wave what? Speak loudly. Then the other one, bridge what? Rectifier. So that's why we didn't choose whether we are going to use half wave or full wave or bridge rectifier. We didn't choose. Stand up. All of you stand up. Almost a half of the class are slumbering. All of you stand up. Okay. So there's a reason for me drawing these two lines. Check Ishkuru. This means live wire, neutral wire. And there's a reason for me to draw these lines. It means that here we are going to have, we might have either, we call it, we have two because we have three wires from the step-down transformer. We might have 3 wires or 2 wires. So that's why I have two wires. And then this is the rectifier. So the rectifier, remember that this is representing the AC. AC, actual alternating, either in live wire or neutral wire. Right? So the rectifier now conveys alternating voltage into direct current. Okay? Are we together? Are we together? So from here, we can draw now the arrow. So the rectified signal, electric signal, the rectified electric signal will be fed in another unit, which we call the filter unit. In electronics and the telecommunication engineering, we have 2 types of filters. We have this, we call them, we have electric filters, and also we have communication filters. Communication filters, we have low pass filter, we have high pass filter, we have band pass filter, we have also some digital other types of the filters. So any telecommunication device, especially on the receiver side, must have filter. Say filter. The concept of filter actually originating from the filter that we use to filter tea, which in Swahili we call it chujio. Nini kazi ya chujio? Inaruhusu nini? Chai ipite. Inazuia nini? Sasa communication filter zinafanya hivyo. Sasa huku hatuna majani. We have electric signals of high frequency, low frequency, intermediate frequency. Have you ever heard them? No, eh? That's why you came to college, to hear them. Okay, so this is the unit. Okay? Okay? Then the next block now. So the filter unit for the power. Actually, it's responsible to filter the pulsating signal from the rectifier unit. And then after filtering, and especially this pulsating signal, it's a combination of DC signal and some AC components. So the filter will allow only DC signal to pass, and it's going to suppress, we call it suppress, the AC components which the filter unit has failed to convert them into DC. Did you understand? No? Peter said no. Let me repeat. Let me what? The function of rectifier unit is actually to convert AC signal into DC signal. Right? Right? Whether half-wave rectifier or full-wave rectifier or bridge rectifier, none of them has efficiency of converting all the AC signal into DC signal. So when the rectifier performs its function, it conveys a certain percentage of AC signal into DC signal. So the signal, the output signal from rectifier will contain large amounts of the DC signal and some AC components. Are we together? Are we together? So the function of the filter is to allow the pure DC signal to pass towards another block and suppress all the AC components which the rectifier has failed to convert the DC into DC signal. Did you understand? Did you understand? The function of chujio is to allow what? T to pass. And the block what? T leaves, not to pass. And you have never think that we have something like that in electronics. So in communication, for instance, if I call my father in Mwanza, the signal that I'll be producing from here, it might be integrated with noise along the transmission line. Okay? So the mobile phone of my father should have a filter unit that will allow the audio signal from the source, that is me, to pass and suppress all the noise signal which have been integrated along the transmission line. Did you understand? Did you understand? Those are the communication what? Communication what? This is not a communication filter. And and the filter actually it's a module itself. But there's no any module of filter. You'll be studying as one of the topic. But the way that it's wide and important in telecommunication, then there's no way out that you can learn within 4 years and cover everything about filter. Then, so remember that. Then the filter unit is just to allow DC and suppress what? Okay? But remember that electronics components or electronic system use the regulated direct current. We have two types of direct current. We have unregulated direct current and regulated direct current. Unregulated direct currents, it means, is a direct current which can change if the input signal changes. That's what you call unregulated direct current. So unregulated direct currents, it means it's not regulated, it's not fixed. And the regulated direct current, we say that is a direct current which is regulated to provide or to have a fixed value. Are we together? Are we together? So here we are going to have another block. Pili said no. So let me teach Pili by writing. So here we have, we have current regulators in electronics. We have voltage regulators. So, because here we have current, electric signal, we have voltage, electric signal, we have power, electric signal. Our interest, most electronics components and telecommunication system uses regulated direct voltage. Okay? So we just need a voltage regulator. So this voltage regulator will be just in dealing with a voltage regulator. Will be dealing with only voltage. It does not deal with current. It does not regulate power. It's just regulating voltage. Voltage regulating unit. Voltage regulating what? So Pili, let me instruct you because you showed me the sign that you didn't understand. When we label the signal, listen, when you label this one, we call it unstepped AC signal. Okay? Eh? This unstepped DC, down unstepped DC signal. Down unstepped DC signal. So this one we call it down, what is stepped dot? AC signal, in terms of the signal. Are we together? Yeah. So again, in other words, this is a AC signal, but it's unrectified signal. In other words, this is unrectified. Unrectified signal. Unrectified what? Unrectified signal. And then here we are going to have what? Rectified what? Signal. Are we together? And then, in other words, this is what? Unfiltered signal or pulsating signal. Okay? Okay? Then here we are going to have a filtered signal or unregulated signal. So Pili, here we are going to have what? Unregulated signal. If you feed this one to the DC or to the electronics or telecommunications components or system, then it's going to function, it is going to cause malfunction. Why? Because this is not sufficient DC energy for electronics components. Okay, Pili? So once this voltage regulating unit does its function, so here we are going to have what? This signal we call it regulated. Regulated what? Regulated what? Signal. Regulated DC signal. Are we together? Yes. This is figure what? Figure what? Huh? Figure 3, eh? Figure 3 or figure what? Figure 3. The detailed block diagram. The detailed block diagram of a linear power supply. Linear power supply what? Linear power supply what? So this block plus this block, this block plus this block plus this block were hidden in one block of power supply. Are we together? So if we redraw now our detailed block diagrams, we will not have forward 4 blocks. We'll have how many blocks? If we redraw our detailed block diagrams of an audio amplifier, how many blocks are we going to have? Many. How many? 7. We will have 1, 2, 3, 4. Microphone, audio amplifier, speaker. But remember that previous we had only 40. 40. Hey, so you will see. Because you saw that the business of design is simple. You just sleep, you just create the